Let's take a look at lesson 4 for linear programming. Linear programming is a method that helps us find the minimum or maximum value of some quantity, given some restraints. The constraints in a linear programming situation form a system of inequalities. The graph of the system is the solution. It contains all the points that satisfy these constraints. So all the points in this shaded region here satisfy these constraints. So we're going to be looking at how do we maximize or minimize something called an objective function. Let's take a look here at the problem that I have. We're going to test the objective function to see which one produces a maximum or minimum. So before we jump into this problem though, let's make a note here. We've got an alert that lets us know that this type of problem is going to show up on our exam in 2 different places. So you'll want to make sure that we make a note of that. And let me pan back just a little bit so you can see that. There we are. Now in this problem, we are asked which of these points maximizes the objective function 2x plus y. So for this one, you're really not going to do any graphing, although we did talk about the feasible region. Instead, we're just testing these points to see which one produces the largest objective function. So what we're going to do is we're just going to substitute the value for x and y here to see which one is the largest p-value. So I'm going to put in 2 for x and 0 for y. So that lets me know that p is 4 plus 0 or just 4. I don't know if that's the maximum yet. I've got to test the other values. So this one, let's put in 0, 0. So still using the same objective function. I'm going to put in 0 for x and 0 for y. And again, I get that p is 0. So I know this one's not the maximum, right? Because it's not the largest value. Next, let's put in 3, 1. So we'll put in 3 for x and 1 for y. 2 times 3 gives me 6. 6 plus 1 gives me 7. So this one's leading, so I know A is not the right answer because we're looking for the maximum. And then the last one, let's do our 2.5, 0, 2.5. So we're going to put in 0 for x and 2.5 for y. And that's not the largest. So that lets me know that C here is the largest, produces the largest objective function value. So pretty easy, right? Just using my x and y values to plug those in. I think that's important. But I think that was pretty simple, right? We can do that. That's totally doable. I think the words linear programming sometimes scare people. So I'm constantly going, yeah, we can do this. We can do this. This is not that difficult. So here is another problem, and let's take a look. Again, I've got a nice little alert letting me know this type of problem is going to show up on the exam in several places. And we're going to have to do the whole thing, right? We're going to graph it, and we're going to find our values to test in our objective function. So first things first, let's graph it. I'm going to begin with the hardest one, which is that x plus 2y is greater than or equal to 8. So if you saw the previous video about a system of inequalities, you know we've got to get that into a y equals mx plus b form. That simply means we've got to get y by itself. So I'm going to take x plus 2y is greater than or equal to 8. In order to get y by itself, I'm going to subtract x from both sides. That's going to leave me with 2y is greater than or equal to. Now, I like my x's to come first, so I'm going to make this as negative x plus 8. And then to get the y by itself, I'll divide each term by 2. And that leaves me with y is greater than or equal to. Now, negative x divided by 2 would be negative 1/2 x plus, and then 8 divided by 2 would be 4. So just to recap, remember that lets me know that m is negative 1/2 and b, or the y-intercept, is 4. So we'll start on the y-axis at 4. And then from there, we'll use our slope. The slope tells me to go down 1, right 2. Down 1, right 2. Now, think to yourself, is this a solid line or a dashed line? Looking at that equal to underneath there, that looks like it is a solid line. So I'm going to line up my ruler here and draw a solid line. If you saw my previous video about coloring in math, this is one of those instances when we get to do that. So we're told that y is greater than or equal to, so that means we're going to the y-intercept and we're going to shade above. So let's do that. Okay, that takes care of that inequality. Next, let's graph x is greater than or equal to 2. So that just means it's going to be a vertical line. I'm going to go over here to 2 on the x-axis, and I'm going to draw a solid line because of that equal to underneath there. So let me do that. And x is greater than, so that means we're going to go to the 2 on the x-intercept and we're going to shade to the right. So I can clearly see some overlap already. This is good. And we've got one more then, and that is y is greater than or equal to 0. So that's going to be a horizontal line at y equals 0 here. And again, drawing that solid line because I see the equal to underneath that inequality. Actually lands in the same place as the x-axis. Funny how that happens. And then I'm going to shade above because of the greater than. So I'm shading all of this above. So you can easily see this nice triangle that's formed where the overlap happens, right? You see all 3 of them overlap in this section here. So I'm taking an extra color and I'm darkening it in so that it makes that overlap show up. Now, once you do all of the hard work to get it graphed, the important points are those key vertices, we call them, where these systems, where this region is kind of bounded by. So let's write those coordinates. This first one is 2, 0. And then this one over here would be 8, 0. And this one here would be 2, 3. Just like we did in the last problem, we've got to test these with the objective function. Now remember, we're looking for a minimum in this one, not a maximum. So we want that smallest value. So x is 2 and y is 0. And that gives me that the objective function is 2. Again, I don't know if that's the minimum or not. I just know it's the value I got. So let's keep testing. We'll put in 8 for x and 0 for y. So that gives me 8. Okay, so I know that's not the minimum, right? Because I know the 2 is a minimum value we've got so far. Let's put in the next one, the last one here. We'll put in 2 for x and 3 for y. And that gives me 2 plus 9, which is 11. Now, obviously, that's not the minimum. So we have found the minimum, right? We found it happens at 2, 0, and the minimum value is 2. So hope that helps with your linear programming for this unit.